Hey, this is Yissachar Abraham. I would like to present my project on computerized methods for tumor segmentations. This was a collaboration between Afeka College and Novacure. In this presentation, I'm presenting the user interface side of the project. The user interface of this project was written as a scripted module implemented within 3D Slicer. Its main goal was to connect all the algorithms to a user-friendly platform and allow intuitive segmentation. So first of all, I loaded this image into the 3D Slicer environment where my module is implemented. As you can see, we can zoom in on the tumor and understand the exact location where our region of interest will be. First, we'll load the image into our model and select the user input data. There's two types of user input data. First is a seed. We can select here two seeds for the watershed algorithm we want to implement. And the region of interest allows us to process only the area we are treating or segmenting and not waste processing resources on other areas, on other regions. Next, we apply these user inputs. This will crop the image. We'll select these into the modules, apply the user input. This will crop the image to interest while keeping its orientation. This to show that we can apply one on top of another, and as you can see, the region of interest is located exactly in the location of the tumor. On the next stage, we can apply some filters. So let's add a smoothing filter, and we can just add like that another edge potential filter, and that is the filter that we just applied. So this is a concatenation of two different filters. One is a smoothing, and then we do an edge potential. At the next stage, we can select our method of segmentation. We pick the watershed and apply the watershed algorithm, and we got a pretty nice segmentation. You can control the opacity over here to lay it over and really see the regions it's laid on. The next stage, we can load our gold standard into the module and compare it with the watershed algorithm we just implemented. So we can select here at the gold standard, number 2 is the necrotic core, and the segment of the watershed is number 1, and we can perform a segment analysis. And down on the bottom here, we can see the dice, the scores of the segmentations are presented. Next, I want to present the other methods in this module. That was the most basic segmentation pipeline, but we can select here the user input, the same input. We can change up the seeds if we want to use the level set. So we can just use the level set algorithm. We can select the seeds, place the number of seeds within the area we want to propagate this algorithm, apply the filters, apply the user input, and then apply our filters that we selected before, and we have our pre-processed image. We can later on go on and picking our level set implementation and apply. As you can see, the segmentation is not really that good. We can improve it either by adding more fiducials, more seeds into the region, reapply the input, and so on. Apply the input and apply the segmentation again, and we got a little bit better segmentation. Now if we compare this segmentation with the gold standard, we will a pretty low dice compared even to the watershed. It's at 0.3. For that, we have this improved segmentation method, and we can select the segmentation we want to improve, and we can apply the improved segmentation. So this method will predict better segmentation out of the current segmentation. We'll try fixing it, and as you can see, it really improved the segmentation to be much better than the original one. And now we can just compare this segmentation, like the improved segmentation, score analysis, and we do get a dice double, almost triple the score of the original segmentation. So next, I'm going to just present to you the GMM. So we can use the same input, the same region of interest, and then we'll just smooth the image, apply the filters. Now, multiple presses on the filters will just re-input the same image into that same pipeline of filter. We can just smooth it intensively over here, and then select the segmentation method to be GMM, and apply the segmentation. So you can see that we get this over-segmented area. This is on purpose because I want to present a good use of the GMM. The GMM was found to be not a very good segmenter, but for this type of use, it is pretty good. It segmented the general region where the tumor exists, and then that segment can be reinstalled as a mask and used to mask out regions that are definitely not tumor. So it kind of localizes the region and allows us to continue and working on an image that's more oriented towards the tumor itself. Thank you very much. That was a presentation on different uses and algorithms within this module. There's many more. Please read my project book to understand the background of these algorithms. Thank you.